Calculating the electrical service size for a commercial garage involves several steps to determine the total load and, consequently, the required service amperage. Let's break down the process step by step. Firstly, we need to calculate the lighting load. Given the area of the garage is 40 feet by 80 feet, the total area is 3,200 square feet. According to Article 220, the lighting load is specified as 0.5 volt-amps per square foot. Therefore, the lighting load is 0.5 volt-amps per square foot multiplied by 3,200 square feet, which equals 1,600 volt-amps. Secondly, the receptacle load must be determined. The question says 180 volt-amps for receptacle load, all with a 100% demand factor. This information looks to be in error. 180 volt-amps per square foot for receptacle load is too high and does not make sense. Therefore, for this example, it will be skipped and not calculated. Now, let's consider other significant loads within the garage. There are two welder outlets, each rated at 50 amps. There is an air compressor with a 20 horsepower motor and a car lift with a 5 horsepower motor. To account for these, we must convert their ratings into volt-amps. The welder outlets contribute 100 amps in total, which we'll use later in the total load calculation with an appropriate demand factor. The air compressor, rated at 20 horsepower, translates to approximately 15,000 volt-amps. This conversion is based on typical values and might vary depending on the specific compressor model. The 5 horsepower car lift is approximately 3,750 volt-amps, again using a standard conversion factor. Next, apply demand factors to each load type to reflect realistic usage patterns. Demand factors are crucial because not all equipment operates at full capacity simultaneously. For lighting, we apply a 100% demand factor as per Article 220. The receptacle load will be skipped because of the error and will not be used. For the welder outlets, a demand factor of 50% is reasonable, assuming that both welders are unlikely to operate at their maximum simultaneously. This percentage can be adjusted based on specific usage data if available. The air compressor is considered to have a 100% demand factor, recognizing its continuous operation during working hours. Similarly, the car lift is also assigned a 100% demand factor, assuming it is used frequently throughout the day. Now we have to calculate the total load. The lighting load is 1,600 volt-amps. The receptacle load is skipped as described above. The welder outlets contribute 100 amps. To convert this to volt-amps, we multiply by the voltage, which we'll assume to be 120 volts, and then apply the 50% demand factor, resulting in 6,000 volt-amps. The air compressor contributes 15,000 volt-amps, and the car lift adds 3,750 volt-amps. Summing these values, we get 1,600 volt-amps plus 6,000 volt-amps plus 15,000 volt-amps plus 3,750 volt-amps, totaling 26,350 volt-amps. The error for receptacle load was ignored for this calculation. Finally, calculate the required service size. To do this, we divide the total volt-amps by the service voltage. Assuming a 208 volt service, which is typical for commercial garages, we divide 26,350 volt-amps by 208 volts, resulting in approximately 126.68 amps. This is the minimum service amperage required for the garage based on our calculations. It's essential to recognize that this is a preliminary calculation. Several factors could influence the final determination of service size. Firstly, the specific equipment used in the garage might have different power requirements than those assumed in our standard conversions. Secondly, future expansion plans should be considered, ensuring that the service size can accommodate additional loads. Thirdly, local electrical codes and regulations must be followed, as they might impose additional requirements or restrictions. It's highly recommended to consult a licensed electrician for the final determination of service size. They can conduct a thorough assessment of the garage's electrical needs, taking into account all relevant factors and ensuring compliance with applicable codes.